Today's topic is Hadamard Transform. It is a non-sinusoidal transfer function. DFT is a sinusoidal transfer function. Last class we have seen DFT. It is a sinusoidal transfer function, but here it is a non-sinusoidal function and it is a symmetric matrix. Hadamard transform is usually written in symmetric form and its smallest order is 2. For order n equal to 2, we have the Hadamard matrix. It is represented by H2 1 1 1 minus 1. It is its order 1 1 1 minus 1. We can generate any higher order by Kronecker product operation. We can generate any order 2n. We can substitute any value for n and it can be generated by Kronecker product operation. For that we have seen H2n is equal to Hn minus Hn. H2n, this n is represented here. So Hn H minus 2n. Now we are going to substitute n equal to 2. When we substitute n equal to 2, it becomes H2n is equal to H2 into 2. That means H4. So we are going to write it as H2 because n equal to 2 here. H2 minus H2. N equal to 2, it becomes H2 minus H2. Now we are going to look how we write this. So what is H2? We know H2 is 1 1 1 minus 1. What is H2? 1 1 1 minus 1. Here this H2 is substituted by 1 1 1 minus 1 and this is minus H2. We have to write minus of H2. So minus 1 minus 1 minus 1 1. So this is the matrix for H4. So H4 matrix is represented by 1 1 1 1 1 1 minus 1 1 1 1 minus 1 1 1 1 minus 1 minus 1 minus 1 minus 1 1. So it can be easily represented like this H2 minus H2. Now we are going to look into H8. When we substitute n equal to 4, it becomes H2 into n, H2 into 4, H8. So each of these is represented by Hn. Now n equal to 4. H4 minus H4. So we have seen what's H4. We have this is H4. We are going to substitute this H4 in one quadrant. This is H4 in another quadrant. H4 in another quadrant. And here it comes minus H4. Here minus H4. What is H4? 1 1 1 1 1 1 1 1. Second row 1 minus 1 1 minus 1. Third row 1 1 minus 1 minus 1. 1 minus 1 minus 1 1. It is same in these three and here it becomes 1 1 1 1. Minus H4 becomes minus 1 minus 1 minus 1 minus 1. Second row is 1 minus 1 1 minus 1. It becomes minus 1 1 minus 1 1. Negative of H4 is written in fourth quadrant. Now we are going to see problems related on Hadamard transform. First we have a function f of x is equal to 1, 2, 0, 3. It is a one-dimensional because it has only one row or it has only one column. So it is a one-dimensional function and fx is equal to 1 by 4 matrix. We are going to find the Hadamard matrix of this one-dimensional function. It is written as f equal to h into f. Since here it is a 1 by 4 matrix, we require h4 here. So h is equal to h4 and we write this f. Why we write f in column matrix? Because now we have h equal to 4 by 4 matrix and f is a 1 by 4 matrix. But these two are not similar. So when we write it in column matrix, we get h equal to 4 by 4 matrix, f equal to 4 by 1 matrix, 4 rows and 1 column, 4 by 1 matrix. So these are similar. This row and this column become similar. Then only multiplication is possible. That's why we write fx in column format. When we multiply this, 1 plus 2 plus 0 plus 3 equal to 6. When we multiply this second row with this column, 1 minus 2 plus 0 minus 3 minus 4. When we multiply third row with this column, 1 plus 2 minus 0 minus 3, we get 0. And again 1 minus 2 plus 3, we get 2. And here another example, f of mn is equal to this. It is a two-dimension. It is a two-dimension. It is represented by mn. It has intensities both m and n direction, both direction. And its size is f of mn is 4 by 4 matrix. So we require a Hadamard matrix of H4. and its equation is F equal to H into F into H transpose. So we have to write first H, then F, then H transpose. Means first row is converted to the first column, second row is converted to second column, third row is converted to the third column, fourth row is converted to the fourth column. Now we are going to multiply these two matrix, and that answer is multiplied with the third matrix. So when we see that H and H transpose are same, that's why it's called symmetric matrix. Hadamard transform is a symmetric matrix. When we multiply these two matrix, we get this value, and it is multiplied by this function, we get this final answer. Thank you.